Welcome viewers. Today we will take biological significance of fructose and mannose. These are the monosaccharides, and we are already doing the chapter carbohydrate, for which you can see my other video tutorials. And this time we will discuss about two important monosaccharides. One is the mannose, and second is the fructose. Mannose and fructose. First of all, let me take this first sugar, that's mannose. Mannose, as you know, is represented by formula C6H12O6, and this mannose is a C2 epimer. This is a C2 epimer of glucose. It means epimers are those isomers which are differing in the arrangement of hydroxyl group around a particular carbon atom. And here it is a C2 epimer of glucose. It means we have substituted hydroxyl group, or we have rearranged hydroxyl group from the glucose at some particular position, and the position here highlighted is the 2. It is position number 2. For example, if I would like to draw the structure of this mannose, I can put it in this way. This is 1 carbon, 2, 3, 4, 5 and 6. Here it is CHO because it's an aldose. Here we have CH2OH, right? And so far as the numbering is concerned, it is 1, 2, 3, 4, 5 and 6. If we see at position number 2, in glucose, we have hydroxyl on this group. But here, since it is a C2 epimer of glucose, the hydroxyl group is not in this side, it is on this side, and here it will be H. Rest structure is similar to that of glucose. It means it is just like this. It is hydroxyl group here, hydroxyl group here, hydroxyl group here, and rest of the places I can place hydrogen. So it is a C2 epimer of glucose. And the stability of the mannose rests in its structure, which is the pyranosic form, not furanosic. It is the fructose only which is stable in furanosic form. So pyranosic form, in order to draw the pyranosic form, again you know it is having 5, it has 5 carbons. This is a ring, hexagonal ring having 5 carbons and 1 oxygen, right? I can put it in this way. This is the structure of mannose, that to what structure which we call as pyranosic structure of mannose. Yes, if I will put OH here, it is alpha, or if I will place OH on the upper side of the anomeric carbon, it will be beta. So rest of the structure is same as that of glucose, but we have a difference here, that is at position number 2. At position number 2, the OH is on the inner side. At position number 3, it is also at inner side, and here it is here, and it is CH2OH. This way we can draw alpha D mannose. Alpha D mannose. This is the ring structure of alpha D mannose. All right. Mannose is a C2 epimer of glucose. This was my point number 1. Second thing, when I see the absorption of mannose in our body, my second point is, if I will see the absorption of mannose in our body, the mannose is absorbed slowly as compared to glucose, and it is absorbed 8 times more slowly than glucose. So glucose is absorbed rapidly in the upper GI tract. However, if we see the mannose, it is absorbed slowly, and the rate of absorption of mannose is 8 times slower than that of glucose. And once it gets absorbed, it goes into the blood, and a part of mannose is metabolized. It will be, once absorbed, it will reach to the blood. Only a part of mannose is metabolized. Rest, I can say mainly a good part, a significant part of mannose is secreted out with urine. It is flushed out with urine. So the absorption is slower as compared to glucose, and it is absorbed in upper GI tract, and it is taken by the blood, where it is metabolized, but only part of it, and a part of it goes with the urine. It has been excreted out, unused by the body through the urine. Then this is the absorption part. And third thing, mannose is not going to get converted into glycogen. It's not like glucose, which is to be converted into glycogen. It cannot be converted into glycogen, or it cannot be stored. It cannot be stored as glycogen was stored in the liver. Our body does not store the mannose reserves. We have no reserve in our body which is made up of mannose, although we have glycogen that's formed from glucose. But mannose, there is no store. It cannot be converted into glycogen. By this way, it has some importance. What type of importance it has? We can use it as a sweetener. We can use it as a sweetener for diabetic patients. For example, we see in diabetic patients, we are not offering the glucose since the glucose is intolerant to them. For example, if I will take another sweetener made up of mannose, this mannose has no property to compete with, or it has no property, it has no applicability, no function where it will be interfering the glucose uptake, or it will be I can say potentiating the glucose uptake. It has nothing to do with that. It is not going to synchronize the effects of the glucose. So therefore, we can use it as a sweetener also. Then fourth function is, it is a very applicable remedy for treating urinary tract infections. It is very applicable in treating urinary tract infections, particularly if the infection is of E. coli. If it is of E. coli, we have seen cystites very common in females and then in males. And this cystites, the probable causative organism for this cystites we have observed so far is E. coli. And this E. coli basically lines the wall of bladder. The E. coli is supposed to lie, or it is supposed to adhere with the wall of bladder. All right. So when we give this mannose, this mannose has a property, because it is being excreted in the urine. I told you a part of it is excreted in the urine. Once we will give mannose, the mannose has a property that it binds with the E. coli on the walls of the urinary bladder, and it detaches them and flushes them out with the urine. So this can be a good remedy for treating urinary tract infections. One more thing, it has some role in fetal development. It has some role in fetal development. We have seen, experimentation has seen, research has seen, if we will not offer, or if there will be no good quantities of mannose to a pregnant woman, it may result in fetal malformations. So therefore, significantly, we have observed there is some role of mannose in the development of fetus, right? So this is one more important function of this mannose. One more thing which one more function which mannose possesses is that if we see it has some role in inflammation, because it is believed that these mannose, the sugar mannose, can activate macrophages. It can activate macrophages, which are the which have some role in inflammation. So what we suggest that this mannose may have some anti-inflammatory role. Also, there is some evidence that mannose may reduce the growth of tumors. It may reduce the growth of tumors. What is the reason for that? Again, it is being presumed that the mannose is basically increasing the number of interferons, or it is simply activating the interferons, and these interferons have some role in the suppression of tumors. So that's one more evidence we suggested that Mannose may be some useful tool, or we can say Mannose may have some action in preventing the rapid spread of tumors, probably by the activation of interferons. And Mannose is a component of every cell. I will tell you how. For example, if we see the plasma membrane has also Mannose as one of the unit. If we see the cell wall of plant kingdom, it has also Mannose as one of the component. So it is found in every cell, every part of the body, every cell of the body. One more thing, Mannose is believed to have some antiviral and antifungal activities. It is also presumed that Mannose has some antiviral and antifungal activities, right? There's a very important alcohol, we can say sugar alcohol of Mannose. Very important sugar alcohol of Mannose, which is known as mannitol. Probably everybody will be remembering, or everybody might have heard about mannitol. If we see mannitol is the alcoholic product of Mannose. If I want to draw it, here we have Mannose. It is 1, 2, 3, 4, 5, and 6. Here it is CH2OH. Here it is CHO. It is OH here, OH here, OH here, and OH here. This is Mannose, right? And if I will substitute it and will form the alcoholic product of this Mannose, here it will be, instead of CHO, it will be replaced by CH2OH. And this is known as mannitol. This is your mannitol. This mannitol is very, very important alcohol, sugar alcohol. You will find mannitol, its applicability you will find everywhere in the system. One, it may be used as a sweetener, very small function. We may use this mannitol as a sweetener. And this mannitol is naturally present in some plants, in some fruits. This mannitol is naturally present, and the important function of this mannitol is it increases the osmolarity of blood plasma. It is increasing the osmolarity of blood plasma. When the osmolarity of blood plasma increases, the water will be drained from the tissues into the interstitial fluid and also into the blood plasma. So by that way, we can use it as a potential diuretic. It can be used as a diuretic. It can remove the excess amount of water if present, excess amount of fluid or water if present somewhere in the tissues. Even the mannitol has a very good function that it can take water away from every tissue of the body, including brain. So we can use it as a brain diuretic also. So therefore it has a use in glaucoma, or whenever there is increased intracranial pressure. It may be used in case of glaucoma, or when there is increased intracranial pressure, we can give this mannitol as a therapeutic agent. We can give this mannitol as a therapeutic agent. So this is a very important role of the mannitol, increasing the osmolarity of the blood, therefore dragging the water or fluid from all of the tissues of the body, including the brain, even including the cerebrospinal fluid. So it will be draining the blood, it will be draining the water, that water will go to the interstitial fluid, and it will then enter into the plasma, and it will be ultimately excreted out through the urine. So this is one of the important function of Mannose, as it is being suggested that it is a diuretic, and we have a number of preparations of mannitol which are in the market and which are used as potential diuretics. Then we have one more monosaccharide which we call as fructose, and fructose is a monosaccharide having the formula C6H12O6. Again, but it is not stable in pyranosic form. The stable structure of fructose is the furanosic form, where we have a ring, in which there are 4 carbon atoms. There are 4 carbon atoms and 1 oxygen, right? Here I can put it in this way. Fructose, I can draw the open chain structure of fructose. It is 1, 2, 3, 4, 5, and 6. Here it is CH2OH. It is not an aldose, it is a ketose, so there is C double bond O. And here also it is CH2OH. Then here we have OH, OH, and OH. The rest of the places I have to place H. Right? This is fructose. This is the fructose. This is the fructose. Alright? Now, this is stable in the furanosic form, and the furanosic ring is just like this. If I will put the furanosic ring here, I have already discussed how to put the open chain structure of fructose into furanosic ring in my previous video tutorials. And here I can say it is OH here, it is OH here, it is CH2OH here. Alright, so this way I can put the fructose here. It is 1, it is 2, it is 3, it is 4, it is 5, and 6. And the rest of the places it is H. This way I can write. And this is, whether this is alpha or beta, we have to see the position of OH group. This is alpha D fructose, or alpha D fructofuranocell. Alpha D fructofuranocell. This is the structure of fructose. Apart from this fructose, you will find it is sometimes called as fruit sugar. We call this fructose as a fruit sugar because it is found in some fruits, like you will find it in some important fruits. One, we call it as a fruit sugar because it is found in the fruits. Second, you will find a good quantity of fructose in honey, right? But there is one important point which we must note. I told you mostly the sugars are dextrorotatory. They are D sugars. But here, in case of honey, the fructose is basically present in LEVO form. You will find the LEVO isomeric form of fructose, and therefore we call this fructose in honey as levulose. So levulose is the name which is given to the fructose when it is present in the honey, because the sugar fructose is found in the LEVO form, not in dextro form. And then the fructose is the sweetest sugar among natural sugars. It is the sweetest. It is the sweetest sugar. Oh, yummy. I think good for outside people, not for Kashmiris, because we relish the taste of salt. We are very much fond of salts. We do not have craving of sugar, but still we are diabetic. Anyways, it is sweetest sugar. It is the sweetest sugar sweetest sugar among all natural sugars. Among all natural sugars, right? And it has a sweetness index. It has a sweetness index of 170. The sweetness index of fructose is 170. One more thing, fructose can be converted into glycogen. Fructose can be used as a source of energy as well, and it can be converted into glycogen. This was not the case with mannose. We can use it as an alternative sweetening agent in case of diabetic patients. But so far as this fructose is concerned, fructose can be converted into the glycogen, and therefore probably it may increase the blood glucose levels also. And one more thing about fructose is that therefore it may serve as a source of energy. And this fructose has one more importance. If you see in case of semen, you will find there is fructose coming from the gland of seminal vesicle. It is the seminal vesicle who is secreting the fructose in semen. Seminal vesicle secretions have fructose, and this fructose is a very good source of energy. Sometimes if we want to know about the purity of the semen, if we want to know about the motility of the semen, we are testing semen and for its energy content, and the index which we use is the fructolytic index. By using fructolytic index, we can see how much amount of fructose is present in the semen, and if we have good amount of fructose, significant amount of fructose, we can say the sperms will be very, very active and motile because of the presence of the fructose, because this is the source of energy in case of semen. You might have detected, you might have seen one more thing. Fructose is present in semen. It is a secretion. And apart from this secretion, you will not fructose present in any of the secretion of the body. Whether it is sweat, whether it is saliva, whether it is something other secretion, or whether it is the female reproductive tract secretion, you are not going to find fructose anywhere except this is present in the secretion, that we call as semen. Therefore, this may be used in vertigo legal cases. We can use if we detect the fructose in any woman, in the reproductive tract of women, we can detect it may confirm as a rape, right? So that's about fructose, and this fructose is a source of energy. I told you it is in semen. And one more thing is it has a role in fat synthesis. It has some role in fat synthesis.